This falls under convection, but it also is very important for us to understand, and it is forced convection. It's where we use a fan. It speeds up the movement of air. We're forcing the air to move. If I move this fan across my face, it speeds up how the air is moving across my face. It actually cools my body better. Forced convection is very important in HVAC. So we have our condensing unit outside that's rejecting heat. The temperature of this coil is warmer than the air. So naturally the heat's going to want to rise up because the cooler, more dense air is coming in. But the process is not quick enough for us. So what we do is we add this fan motor. By having this fan motor, it makes it forced convection. It actually pushes this air up and it causes a pressure drop that pulls more air in. So we're literally moving air across this condenser faster, which speeds up heat transfer, speeds up the second law of thermodynamics. This is a very important piece of what we need. On the inside, we also have forced convection going on here as well, such as our gas furnace. We're using the blower motor there to force or push air across this evaporator coil. The heat leaves the air and goes to the cooler coil. So we're speeding up the process. Now we're pushing that air into the house and causing that air to mix in the house to become a more comfortable conditions. On this electric unit, we have something very similar. We have our blower motor that we're pulling air across that evaporator coil. So we're causing heat to transfer from the warmer air to the cooler coil, and that's cooling the air down, and then we're forcing that cooler air back into the house. So this is forced convection. Forced convection is a very important aspect of HVAC. Another thing that's very important to consider is a fan alone does not cool a house down. A lot of people leave their fans on all over the house thinking it's cooling the house, but that's not true. What it's doing is circulating the air, and if anything, it's actually heating the house up because of the heat that the motor itself generates. A fan helps you feel cooler because remember, your body is an engine. Your body is creating heat. It's putting out BTUs of heat energy. By having a fan run against you, you're taking the air that's cooler than your body and you're moving more air across your body. This causes heat transfer much more effectively. So in other words, your body is giving up heat at a faster rate, so it's cooling your body down, which makes you more comfortable, and that's very, very important. Now on that same note, a fan that can make you feel cooler doesn't mean that's the save-all. In the wintertime, we want to make sure that we don't have any air movement because we want the heat to be around us. We want to feel warmer. Now on that note also, when an AC system comes on or shuts off, you should never know it. You should never hear it and you should never feel it. If a customer feels when the air conditioning comes on, then it's an improperly designed system. Now a fan locally used can help you feel more comfortable and helps you offset the temperature. In other words, in the summertime, I keep my thermostat at about 80 degrees. By having a fan on, moving air across me, it still feels very comfortable. It's something to get used to. I know people freak out when I first tell them that, but as people start to embrace this and they start raising their temperature up slightly by using a fan, it makes a huge difference. A lot of people, even when they sleep at night, like to have that big, thick, comfortable blanket on. They actually make a bed fan now. It's a fan that fits underneath the bed and it blows air between the sheets. By moving air across your body, it helps your body feel much cooler. It actually cools your body off more effectively. Instead of cooling the whole entire house down to a low temperature, you can make your body much cooler and save a whole lot of electricity. Forced convection, the movement of heat through fluids, areas of fluids, by force. We can also have forced convection in plumbing or hydronics as well. We use an actual pump and we're pumping water through. Let's say we have a water heater somewhere, we're heating that water up and we're forcing that flow of water through the floors. Then the floor transfers heat by conduction to the air then transfers heat by convection, warming up the house. Tons of different options, but now you're thinking about the movement of heat a lot more effectively.